You're following, personally, I'm following monocrystal for a long time. The oldest books that I have are from '77. Mainly Japanese companies are very eager to get results done, and maybe you remember things like glass ferrite heads in Akai and Sony tape decks, and they had parts that were monocrystal already in that time. It was very unique. Every researcher is searching for the perfect structure of metal. It makes it, let's say for an engine, if you could make aluminum parts in monocrystal or non-crystallized, the wear is much less, so an engine will not break as easily, can run with higher revolutions, will deform less under temperature. So there are a lot of benefits. Also electric is better, that's our interest, of course. There are a lot of benefits from making this non-crystallized or sometimes single crystal materials. Basically there are two ways. Glassy metals, which is no crystal structure whatsoever. Monocrystal, which actually acts like one large crystal, and the end effect is not much different. So we have three types of wire in our factory, and they are made with three totally different processes.
Okay.
And I don't think I should disclose the process.
Sure. I'm curious, with Crystal Cable being such a different cable, not only from Siltech, but a different cable to many of the high-end cables in terms of its gauge. Are some of those single crystal processes applied with the Crystal cables?
Not yet. Until now we use the silver gold alloy metallurgy. Actually, maybe I'm giving away something new, but we are planning a new line, and that would be the first crystal cable line with monocrystal conductors.
Interesting. And will that apply? Will there be interconnect cable, loudspeaker cable, video cables throughout the whole line?
Well, I think we would start with the audio range, so that would be interconnect, speaker cables, and power cables.
Right.
And I think the monocrystal technology is we will be able to apply it also for digital cables like firewires, USB.
Yeah.
So, but that would be a later step.
Sure.
I think you could safely say that 5 years from now, all our products will be based on amorphous technology, between glossy metals for the whole range. That's a slow process that we have to do one step by step.
Sure.
Also because the laboratories making it still are not able to make it in any serious quantity.
Yeah.
So that's why so far it's limited for our top models.
Sure.
And that slowly you will see that trickle down to
the other models.
more affordable models.
Sure.
Yes.
Okay.
With Crystal,
Sorry.
with Crystal we had some experience with the silver gold technology, not only using it as a conductor, but also with the Dreamline, the most expensive series. We also use gold wires in the shield, so it's not only visible, so everybody can see the silver gold construction, but it also adds to the sound.
Sure.
So that was the last development for Crystal.
Okay.
And now we are topping it with probably monocrystal wiring.
Sure.
That's something new for probably 2012.
The running in of a cable, there seems to be a contentious issue.
Yeah, well, that's absolutely scientific. Running in, let's put it this way: if you have a roll of high quality, high purity material, silver, gold, both, copper to a certain extent too, you can test the softness of the wire that you have, and that's a little V-shaped hammer. You just drop it on the cable, you see how deep the dent is. That's basically a standard test. If you don't do anything with it, you put it on the shelf, after 2 years it will be softer. So the dent will be deeper. And this is a well-known property of all rare earths, at least silver, gold and copper. And the reason is this, that during the manufacturing of the wire, a lot of damage is done to the surface of the wire. And you can polish it, but won't take it away. So there are incomplete crystals. Crystal is like, let's imagine a sugar cube. Every corner is an atom, and the atom is like a little magnet, and it locks into the next magnet of the next sugar cube, the next grid. So that's how the grid is built and how crystals are built. During manufacturing, there are, because you just press or squeeze, there are many ways of doing it, but usually you press wire through a hole in a plate with a little diamond inside, and you get a wire out of it, and the outside will be damaged. You don't see it, it looks smooth, but under a good microscope you see exactly what I'm talking about. That surface during room temperature, with 20-22 degrees on average, it's enough to make the atoms shake. Atoms just move back and forth, and the higher the temperature, the faster they do, and the more space they need. So they go a little bit further. That means that with a little bit higher temperature, there's a big chance that they will come so close to the other little magnet, the other little atom, that they link together and form a new crystal. That really means that the surface area of the wire gets smoother over time. There are two ways to increase it: put some current through it, or raise the temperature. So put your cable in boiling water, and you will hear what I mean. Just leave it there, let it cool off nicely, don't do anything, don't take it out, shake it, just let the water cool off. The next day your cable will sound better.
Right.
High current through the cable will do exactly the same job, but we discussed that a little bit, because some brands of cables can't handle very high currents, because then it could be a fire hazard. In the case of Siltech and Crystal, and Crystal of course is very deceptive, it looks like very thin cables, but even the thinnest one you can put about 20 amps through it, so they can stand many amps without any risk. And then you speed up the smoothing of the surface very fast, and you really get a better sounding cable, because it lowers the impedance. That's not much, but the second effect is the lowering of the distortion. Especially the higher frequencies tend to use only the surface area of a cable. The lower frequencies, they penetrate the cable more deeply, up to a millimeter. But the surface area, the higher the frequency, the more only the surface is used. And that means that if that looks like a rock road or something like that, how do you call it, a dirt road, there's a lot of electrons that don't move in a straight line, they have to jump all kind of directions, increase slightly the impedance, but most importantly, create audible distortion. So breaking in is just lowering the distortion, making it sounding smoother as a side effect from that.
Sure.